So, black holes. Yeah, we know they bend space and time, but let's be real. The biggest question is, what actually happens if you fall into one? The answer isn't just weird. It might completely change how you think about reality itself. Okay, let's make this personal. Forget about telescopes and abstract physics for a second. What would you feel? A brutal, crushing end or something much, much stranger? Okay, let's make this personal. Forget about telescopes and abstract physics for a second. What would you feel? A brutal, crushing end or something much, much stranger? Let's find out. To figure this out, we're going to have to take a little trip. It's a thought experiment, a one-way ticket into the deepest gravity well in the entire cosmos. Okay, picture this. You're suited up, floating in that perfect, silent void. And right in front of you, there's this patch of absolute blackness, a circle of nothing that bends the starlight around it. Your mission, should you choose to accept it, is to fall in. You know, every epic journey has that moment, right? The point of no return. And for a black hole, it has a special name, the event horizon. This is where things get really interesting. Now, this isn't a physical wall you could bump into. It's more like an invisible threshold. It's the exact point where gravity becomes so ridiculously strong that nothing, not even light itself, can escape. Cross it, and there's no going back. Ever. And here is the first absolutely mind-bending twist. As you approach and then cross that invisible line, you feel absolutely nothing. No jolt, no flash of light, nothing. From your perspective, you're just peacefully falling through space, completely unaware that you've just passed the point of no return. But here's the thing. While you're having a perfectly normal, floaty time, someone watching you from a safe distance, let's say your friend on a spaceship, is seeing something completely and totally different. This is where our one single reality seems to split in two. So here's where it gets weird. From your point of view, you're just you, a three-dimensional person falling freely towards the center. But for your friend watching from far away, as you get closer and closer to that event horizon, they see you start to slow down. They see you stretch, get dimmer, and finally just freeze. A two-dimensional image of you seemingly plastered onto the surface of the black hole forever. So wait a minute. Which one is it? Are you inside the black hole or are you a flat image on the outside? Because you can't be both. And this dilemma creates one of the biggest puzzles in modern physics, something called the information loss paradox. See, this whole problem bumps up against one of the most sacred rules in quantum mechanics. Information can never, ever just be destroyed. And when we say information, we mean the unique quantum state of every single particle that makes you, well, you. It has to be preserved. It has to go somewhere. And just like information can't be destroyed, it also can't be cloned. You can't just copy and paste it. It's not allowed to exist in two different places at the same time. That's a fundamental law of physics. Which brings us right back to the big, impossible question. Is your information falling to some unknown fate inside the black hole, or is it stored on the two-dimensional event horizon, just like your friend sees? It simply can't be in both places. Physics literally breaks down trying to answer this. Trying to untangle this mess it's pushed physicists to the absolute brink of what we know, forcing them to consider some truly radical ideas about the very nature of the universe itself. One of the most profound ideas to come out of all this is something called the holographic principle. It suggests that our entire three-dimensional universe might just be a projection, a hologram of information that's stored on some distant two-dimensional surface. And think about it, the black hole paradox is kind of like a mini version of this, right? Maybe both realities are true, because the 3D you that's falling in is the holographic projection of your 2D information stored on the surface. And that's where we're left, with this really unsettling question. The black hole acts like a cosmic mirror, showing us that two observers can see two completely different, yet equally valid realities. And it forces us to ask, if your existence is one thing to you, and something totally different to everyone else, what does it even mean to be real?